Okay, I think we have everyone online now. So welcome to the Trimble webinar, Robotics at Your Service. And as we gave you the promise of encountering the challenges in network planning with ease, so during the next hour, you will hear what the role software robotics plays in the planning of electrical network, and more importantly, what benefits it can offer you. And if you're worried about what will happen to the role of human beings in all of this, you will also get an answer to that question. My name is Sanna Selikare. I will be your webinar host today. And with me, I have Sales Director Jukka Leppänen.
Hello, everyone.
And Product Manager Eero Saarijärvi.
Yes, hello.
And Eero has a strong background on this topic since he is also a scholar expert on the field of network optimization. So stay tuned. If you have any questions, you can write them down to the GoToWebinar chat, and we will go through the questions at the end of the presentation. So thank you for joining us, and let's get on with it. Please, Jukka, the stage is yours.
Okay. Thank you, Sanna, and hello, everyone. Good afternoon, and nice to see so many people interested about the robotics. So let's go on. We have only 1 hour time to go through quite, let's say, wide topic in a way, but our agenda for this day or this 1 hour is so that I'll start with the introduction. Then Eero continues with the demo part, the most important slot in our presentation, and finally I summarize very shortly what we have heard today, and at the end of our presentation, of course, place for your questions, and we try to answer, of course. So let's go on. During the introduction, there are two main objectives. I would like to first open the situation today, how network planning is typically done in utilities, and on the other hand, I would like to introduce how robotics could change the way of working in utilities and what kind of benefits can be achieved by robotics. Let's start about the planning process today, typical planning process today. So as you know, the network planning today starts from modeling. So all those needed changes, what you are going to do in your distribution network, should be modeled. Some components should be deleted, something added, some lines should be selected, some line routes should be drawn, and so on and so on. And when that basic change modeling has been done, it's possible to continue and check the technical feasibility of your planned changes. And normally different kind of power system analysis applications are used for that purpose. And depending on utility, as a last stage, when technical network is ready, some utilities calculate costs for the planned changes, and typically calculation covers only those investments costs, like what are the material costs, what are the labor costs, and so on, if we implement those changes. And when you need to compare different alternatives to implement your changes in network, that means that you go through those 3 steps few times, as many times you would like to check different technical alternatives, for example. That's the basic process in many utilities today. And this process causes some challenges as well. I start from the planning part. And when doing the network planning, basically you should consider every single time few different things. First of all, you need to check that technical quality of distribution with the power system analysis and so on. But on the other hand, you should be sure that network you are constructing or editing there should fulfill your needs regarding the distribution reliability. And finally, all decisions should be based on economical impacts. What kind of costs this change will cost to my company? And when considering all of these different aspects, not only the technical quality of distribution, and together with the ongoing transformation of energy system like DERs, electric vehicles, and so on. Plus, if you would like to play with the different technical alternatives and consumption production scenarios, it means that with the traditional way of working and planning, it sounds very laborious and time-consuming job. And we really believe that that's maybe impossible to perform in good manner. In addition to challenges in network planning, there are some challenges in asset management as well. First of all, when doing that network planning with the traditional tools, those plans or those outcomes from network planners, they are not comparable with each other because of maybe there are some differences on persons, like how experienced person is, how well he or she knows the local environment and the circumstances in the nature in the field. Or sometimes it's also a question about how much time they are able to use for network planning. But there's some other challenges as well. In very large projects, and because of lack of time, it means that can be so that network plans where all investment decisions are based on, they cover only some part of the network. For example, they plan the medium voltage part of the network, but the low voltage networks are without real network plans. There are maybe somewhere are some jump rules are used to estimate what are the economical impacts of low voltage network. And sometimes, of course, because of those tools and time needed to analyze, there are also some lack of information or scenarios, or also maybe insufficient analysis of all different costs caused by network changes. So there is a big risk for investment decisions based on maybe incomplete or insufficient information. Could robotics help in those challenges? What if the planner just selects some few details, defines few things there, and press a magic button, and then the application starts to create those network models, selects feasible line types and fuses, places different switching devices in specific locations, checks different line routes. Should I go under the lake or go to over the bridge? Calculates economic impacts, all of those topics above there, and returns in few seconds optimal solution, which is technically always in accordance with utilities, network strategies and planning guidelines, and they are always based on consideration of all economical impacts over the network life cycle. And today we are talking about the network, Trimble Network Optimizer, that magic green button to do that what was for maybe the promise in the previous slide. So Optimizer is a software robot at your service, helping you, and it really performs those laborious planning routines and helps the planner to find that most optimal solution per planning case. The optimization itself is based on minimization of life cycle costs, including investment costs, technical losses over the calculation period, and outage costs over the calculation period. For example, 20 years, 30 years, whatever is used in optimization. But the important thing is there that we have not hard-coded what is the optimal network. The optimal result or outcome is always based on utility-specific parameters and configurations, and how they would like to control the outcome. They can define, for example, those electrotechnical limits like voltage levels, load grades of lines. They can define if for a medium voltage network all secondary substations are reserve feeded or not, and they can also define what are the preferred object types when constructing new networks. So it's really configurable, and each utility has a possibility to influence what is the optimal network or outcome from optimizer in their environment. Optimizer can be used for different use cases. We have identified these four as a main ideas or planning cases. It can be used in medium voltage site, for example, for identifying optimal locations and types of switching devices. It can also be used in medium or low voltage side to analyze connection requests by end customers. They would like to construct new solar panel maybe somewhere, or they would like to construct a new house somewhere and ask that this is my connection. Is it possible to connect to your network? This is very common use case, I guess so. But also, of course, it can be used for more common project planning, network renovations, new living areas or suburban areas where you need to build up totally new network. But it also can be used for defining target networks. Then we are talking about long-term planning, that if I could, and I have maybe 10 or 15 years time to make an optimal network, considering all those changes happening in my network, new growth of population or maybe something else, new industrial areas, something like that, and you need to define that what would be my or should be my target network in long term. Then optimizer could help to analyze different scenarios as well. Before Eero's demo, I would like to introduce the optimizer by slides and go through couple use cases. And this first one is a renovation of a low voltage network. how optimizer works, it's basically like this. So planner selects or defines the needed input data. In this low voltage case, it means that he should select or add location of distribution substation or substations, and then that low voltage connection points, location plus consumption information or production information if there is some distributed energy resources installed. And maybe in case of renovation, he or she should also define what existing lines should be kept in the future as well. But after that, when selecting those few components, in this case, one distribution substation, 15 connection points, he or she presses that magic button optimize, and optimizer returns correct line types, makes protection calculations, defines needed fuses, finds the most cost-efficient line routes between the nodes, and proposes also those location of low voltage assemblies, distribution cabinets. In this specific case, it took only 15 seconds to find optimal solution. Very similar or analog cases is medium voltage size. In this case, this is greenfield planning we call it, and the objectives is to define target network in certain geographical area. It means that the planner selects substation and location of substation plus location of distribution substations plus that load information behind the secondary substations. And then press that same optimize button. Optimizer returns correct line types, cost-efficient line routes, optimal switching devices, location and types of those. Plus, there's also how that network should be run in normal situation. In this case, again, one main substation and over 80 distribution substations. Target network was created in 15 seconds. So hopefully you got the basic idea. Eero will continue with the real demo and go in much more detail how optimizer works and what kind of things it does during the optimization. But this was the kind of high level introduction what we are talking about and how optimizer could help your network planning in the future. Okay, and before Eero, we would like to hear your opinions about those possible use cases. And the question is that which of the optimizer use cases below do you find most interesting in your environment?
And we have the poll active right now, so you just select the items on the list that you find most interesting. We'll give you a few seconds to answer to the poll before we will reveal the answers to you as well and go through them. We're still getting few votes in, so giving you just a bit more time to answer the question and think it through on which one of those options are the most interesting ones from your point of view. The switch optimization, long-term planning, analysis of connection requests, planning of LV networks or planning of MV networks. And it seems that now we have the votes coming. So I will close the poll and share the results with you as well. So the most popular use cases was the planning of medium voltage networks. And the second most interesting one was the planning of low voltage networks. But all of the different alternatives got votes between 42 to 84%. So all of those different use cases you found interesting, but the LV and MV networks seem to be the most interesting ones at this time.
Thank you very much for your input.
Yes, it was interesting to see and hear what your thoughts are on this topic. And thank you, Jukka. We will now move over to Eero's presentation and the actual live demo of Network Optimizer. So I will give the presentation for you, Eero.
Okay, thank you. Thank you, Sanna and Jukka. I hope you can see my screen now.
Yes, we can see your screen.
So I will keep the introduction to the minimum. Jukka had an excellent introduction to the topic already, so I will keep the slides as minimal as possible and focus on the real demo more. But anyways, a very quick intro or approach to the demo from a little bit different angle. So this is the way I've been telling the story, or kind of the evolution of planning. So we know networks have been planned in the past with the various tools, not so digital, very analogous planning has been done. The networks which were planned using these kind of tools, they are still working very fine. There's nothing wrong with it, but still we believe that when the computers and calculators came along, the efficiency definitely increased, and the same planner can just do much more. Today we have a fully integrated calculation in NIS, and that's actually something that is globally thinking. For example, in Germany, maybe not so common. So we are definitely in the very front of the development with our software today. However, we do believe that this is not the end of the evolution, but in the future something more will follow. And one of the branches or one direction we believe which this development will go is that robotics and artificial intelligence, all kinds of computer-aided tools will be a more important part of the planning process in the future. So guessing or predicting future is of course impossible. You can make guesses, and our very strong guess is that these kind of new assisting tools will be helping the planners in the future. They are not replacing the planner. They are helping the planner so that the planners can focus on the real challenges that the network companies are facing in their operational environment today. I'm sure that many of you in the audience, you do share the feeling that the distributed energy resources is coming more and more important in the planning environment. Electrical vehicles is another thing. What does the climatic change do for the networks? More risks for the overhead lines. What does it do for the consumption patterns and so forth? So there's many kinds of inputs in the operational environment that might be a little bit uncertain, unknown, and to be able to handle those, we need efficient tools so that the planner can make scenarios and master these kind of inputs. About low voltage network optimizer, the main benefit is the efficiency leap it enables in the planning of low voltage network planning. Of course, to fully get the benefits, some of the processes, traditional processes, have to be changed. And one example use case for low voltage optimizer, proven use case, is that actually the planner, while the planner does planning of MV network, the planner can just with one click do a realistic plan for the LV networks in the area of where this MV planning is being done. So this in turn gives more realistic and more accurate data for choosing the correct investments and compare which of the investments should be implemented and which should be postponed. And also there are some savings potential in the for example, in the outsourced planning expenses, but what I've heard, definitely this is not necessarily the #1 benefit, but instead the better management of the overall investments is the key benefit. Okay, but let's go into the details about network optimizer. So how it works? It works from NIS, Trimble NIS. So the user can just work through plans in Trimble NIS as normally. All the planning tools that are being used in the planning normally are still available. So Trimble Network Optimizer is just an assistant that very quickly gives a plan where the planner can then start improving and making some minor changes. So let's have a look how it looks. I'll switch over to Trimble NIS and Optimizer now, and I make a small low voltage network plan to start with. I choose the data region I want to do the planning in. So in this case, I have one secondary substation. I have 3 consumption points here. I have the required input data for the dimensioning of the network. I have the main fuses. I have the consumption data. I have the transformer size, what kind of transformer there is on this substation. I have all the needed input data automatically fetched from NIS. I just choose the area, click go, wait a little while, and then what Optimizer does, it proposes me a plan for this area, which can if everything is fine, the planner thinks that this is fine as a preliminary plan. It can be handed out to a further, more detailed terrain planning, for example. Then that's fine. It'll go there. Otherwise, if the planner sees something to improve or something suspicious, all the tools, PSA, CPP, are still within one-click reach here in NIS, and those tools can be used as normal. A Trimble Network Optimizer calculation is running on a service, REST service. So it means that the calculation server can be on premises, or it can be also located on a cloud server. So depending on what kind of how much use and what kind of requirements there are, Trimble can also have some service way of providing this calculation to end customers. And only in this case, only some very small installations have to be done on the customer side. Background map is very important in the planning of Optimizer. So not only it's a visual aid for the planner, but also it acts as an active driver in the planning. So in this case, we see that the lines are following the roads cable boxes which were placed automatically. They're placed along the roads. So planner has full control on the parameterization of the background map, and planner can define which type of terrain, for example, roads can be favored, fields and field edges can be favored, rocky terrain can be avoided, and so forth. So whatever information is available in the background map, that can be freely configured by the user to get the desired result. Those are generic features of MV and LV optimizer, but now next let's have a look on the details of LV optimizer specifically. Load flow in network optimizer, we have a load flow calculation built in. We are carrying out typically hundreds or thousands, in some cases millions of load flow calculations for the network while we are doing the manipulations and aiming to the cost optimum network. So it has to be very quick. However, it has to be accurate enough. We are able to handle hourly data in the load flow calculation. So with this built-in accurate enough load flow calculation, we are able to ensure that the loading of the lines, loading of the transformers is kept within the allowed limits. We make sure that the voltage drop is not more than allowed. And of course, if there's a lot of renewables injection to the grid, we are watching after the voltage rise in those cases, and the user can set the limits for those voltages for normal operation and for contingency. All of this, all the consumption data is being fetched automatically from NIS, so the user only has to select the consumption points that are wished to be taken into the analysis, and then optimizer automatically fetches the consumption profiles from the NIS database and according to the calculation parameters. If there's hourly data available that is being used, or if the index series is the way to go, then that's also possible. And of course, the results when the network is being drawn to NIS, the planner can call for the second opinion from Trimble PSA and verify that the network really is according to the boundaries. In addition, Trimble Optimizer has short circuit calculation, which is needed for primarily for the minimum one-phase short circuit requirement enforcing, and also it is needed for the fuse planning, where we are guaranteeing that the safety requirements are being fulfilled, and in addition we are aiming to a good selectivity. So we can take a look from here how it looks. So this cable box was being drawn by Network Optimizer, and if we now take a look inside, we see that Trimble Optimizer has direct busbar connections here for the feeding side, and then this customer point is being connected with a 63 amp fuse, and then we are continuing to the other. Actually, this is the other line, which is also directly connected to the busbar. So fuse planning is based on built-in short circuit calculation and and the results of this can be then verified using the Trimble NIS PSA. Low voltage assemblies. Actually, I saw in Jukka's presentation, was there at least 2 or 3 names for this. It was called distribution cabinet. Sometimes there are cable boxes and LV assemblies, so it seems like the precious child has many names. It's very important in the planning of low voltage networks. And what also is very important, that the types of LV assemblies that are being used in the planning of the network, low voltage networks, can be configured and defined by the utility. So I can show you here what kinds of models we have available. For example, in this definition group, I have all of these separate LV assembly groups available, and for each of the group template, I can define what kinds of lines and what kinds of fuses can be fitted into the terminals of the assembly. And with this, we can guarantee that the cable boxes optimizer is proposing here, they really are such, they really are corresponding to the real network, real distribution cabinets that the network utility would be using in the real construction. So when we are calculating, for example, the network cost for the plan using CPP, we also get the correct types of cable boxes in place and a very accurate cost for the whole plan. Cable box locations are also, or cable boxes can be also placed automatically by optimizer. So as we saw in this example, I wasn't providing any cable boxes as input, and in this case, optimizer is searching for where to put the cable boxes so that, for example, the 200-meter rule for the customer line is never infringed. So these kind of rules are complied. If, however, the planner wants to put the cable boxes manually on place, that is also possible. Subfeeders are being used. So as we saw here in the previous example, so one fuse can contain 2 lines. So this is something that we do consider in the planning. And in addition, if the cable boxes are such that we have the metering device here at the where the actual cable box is, those types of configurations are also possible. One of the lately developments that we have done with optimizer is called brownfield assemblies, and what it means that with the ability to consider brownfield assemblies, optimizer explores how much free capacity each of the cable boxes included in the calculation has, and then it either keeps an existing cable box and if needed and if allowed, it may also propose a new cable box for some location in a case where the lines that should be fitted into the cable box just simply won't fit. So let's have a look on this kind of a use case next. So I use the same plan as or same network we made a while ago. I'm adding one customer point here. I'm not adding any consumption here. If I would, from the consumption point, that would be directly be used by the optimizer. But let's just in this case simply let the main fuse do the dimensioning. So we have the 25 amp main fuse there, and that will dimension the line anyways. So I just choose the network, not only the feeding point, DCP substation, and the old customer points that were in the previous calculation. In addition, I'm choosing the lines that I want to include in the calculation. And in addition, I choose the new customer point here, which I want to investigate that which of the cable boxes in the existing network would be the ideal location for feeding this 25 amp new connection point. So I have an answer here. In this case, we found out that this cable box here has enough capacity, so it can be fitted here. So there was a free terminal where this line could be fitted. What we saw here, first we saw greenfield planning, where we are only providing the consumption points, distribution substations. We were seeing a brownfield calculation where we were keeping all of the lines. We were just adding one consumption point. Another very important use case for low voltage planning is so-called brownfield, full brownfield planning, where we are not only considering some of the network objects as input, but in addition, we want to get rid of some old lines. So in this case, the company can predefine so-called rules. I have a few options here. I go with the basic. I select the network as normal. I trust my predefined rules. I can see what lines would be removed from here. Optimizer knows, following the rule, that which of the network components would be anyways removed in the renovation. It does it first, and then rest of the lines which were considered still valid, were sent to optimizer, and it uses those in the planning so that only the necessary parts of those lines or components are being replaced. And in this case, as we see, none of the existing lines had to be replaced. It was all of the technical boundaries, for example, short circuit voltages and so forth, loading of the lines, loading of the transformers. There was no problems with those. So all of the existing components could be kept, and only the parts where we were removing the AMCA lines had to be replaced with new lines. Of course, the network topology can change a little bit. With the previous connection was coming from here, the AMCA line, and now we have a cable box here, and this is a shorter connection. So optimizer chooses that one. If there are customer-owned lines, like in this case, I believe there were, some of the lines are being owned by the customer, liittymisjohto in Finnish. So those kind of lines can never be removed, no matter how bad they are technically. We see that these are quite small, 16 square millimeter. However, and this is 10 square millimeter, they have to be kept. And in this case, optimizer does the planning so that they are being kept, but still all of the technical conditions are checked at each point of the network. So even if the bad and the weak lines are there, dimensioning of the rest of the network is where we are taking care and making sure that the network we are proposing as outcome is according to the guidelines and rules. Cable trenches are being drawn also for the new lines. So if we take a look from here, let's disable elements and parts, get a little bit better look. So of course there was this existing underwater cable here, so we don't draw a cable trench there. But for the other parts of the network, also here was an AMCA line that was kept, no need for cable trench. But for wherever we have new cable installations, there we are also drawing cable trenches, and also so that the underlying environment, if it's rocky soil or normal condition, or however the company wishes to configure it according to the background map material, those can be separated from each other. And of course, that again can be taken into consideration of CPP calculation, for example, to get a good estimate for the project cost. About the cable trenches, their output, but in addition, optimizer can consider cable trenches as input, and I'm showing an example here. I'm importing some pre-made lines here in this region, just any line object. In addition, I have some customer points to make it quick. So in this case, this is not really maybe a realistic plan, but it's just aiming to give an idea that if there would be a new residential area plan, you can just import the road, for example, or the street network in that area. You put the places where the consumptions are. You have to put the distribution substations into place, and further you would of course add some consumption to these consumption points based on some zoning. Maybe you know from the zoning data how much consumption there is expected, so you would add that. When that's been done, you click go, and as a result we get a network where the road network is being considered as the favored place for putting the cables. So let's disable the disable the trenches now. And we get a proposal for this area rather quickly. So if, for example, where we don't have the required data in the background map, we can also bring some of it from some shape files or other vector data. Okay, that was it very quickly. Maybe I now hand over back to Jukka and Sanna for closing the.
Yes, thank you, Eero. And Jukka, I will give you, or I will make you the presenter again, so you're able to share your screen. Or we can't hear you, Jukka. You might have your mic on mute.
No, yeah,
Yes.
lips were moving, but no sound. So you can see my presentation right now.
Yes, yes.
Good. So let's thanks Eero for demo. Lot of stuff, of course, and in such a short time. Hopefully you were able to pick up the most important points there, and we won't disappear anywhere, so please contact us if any further questions and so on. But let's summarize what we have heard and seen today. Yeah, we have a ready-made software or applications for helping network planners in their work, called as a Trimble Network Optimizer. First of all, it's really, like you saw, it's a really powerful tool for different planning tasks. It can be low voltage, can be medium voltage networks to be planned, can be new constructions or renovation projects, or just defining kind of long-term target networks. There's always optimal network structures as an outcome, and when we call it as an optimal network structure, it means that both technical and financial aspects are considered systematically every time according to parameters, and parameters are really utility specific. So optimal network in certain utility can be totally different than in neighboring. It can be different also inside the one specific utility, because it's the planning outcome is really depending on environment as well. It can be different kind of network when we are talking about the city work networks, or we are talking about the rural networks, and compare those to each other. And with the optimizer, utility can gain savings over the network life cycle, meaning that they can gain benefits in the meaning of capex or opex expenses, and the capex means that, of course, depending on parameters, they can gain some benefits as investments, but also we need to remember that the optimizer calculates also those life cycle costs in the meaning of losses and outage costs. Then Sanna introduced at the beginning that, okay, maybe we should answer if any humans are needed in network planning, and my answer is that yes, we have a really great and powerful engine and robot, but professionals are needed to drive it all the time. And like you saw in Eero's demonstration, there were a lot of cases where Eero did something before the optimizer selected some components, maybe some cases gave new initial data before the optimization, change the load information, whatever it is, but it's a helping tool, and network planners are needed, but it can really help their work a lot. So that's all I have prepared. Now we have a few minutes for questions. At least I can stay online if longer than a few minutes if needed. Is there anything in chat?
Yes, so we have a few questions for you. So hopefully we will also get and have Eero online available to answer these questions as well. Okay, good. So let's start. First question, does optimizer take into account selectivity of fuses and circuit breakers?
Yes, fuses, yes. For LV planning, definitely we are always aiming for good selectivity. That's not a hard requirement. So if there's really no way, and especially if there's a lot of brownfield constraints or requirements, such as that you are not allowed to add any fuses to brownfield network, brownfield meaning the existing network. In those cases, it might be impossible, but that's always the target. We are always aiming to good selectivity, minimum of 2 fuse sizes step in between the consecutive cable boxes. As we saw in the example, actually there was just chaining through the cable box, and that's another parameter where you can define in some rural networks the customers wish, so that the cable boxes are typically just chained through to another, and only the customer lines are fused when needed. But that's for the LV planning. For MV, and that we have circuit breakers in MV side, medium voltage, and there the driver for switches is reliability also. So with that regard, yes, we are indirectly aiming to selectivity, but that would maybe require a little bit more discussion how that exactly is, how to consider that exactly, selectivity in MV side.
Okay. Next question. Is it possible to define maximum voltage drop for each node for optimizer?
Actually, let me think. I think currently no. We do have the nodal voltage drop results from the master results of NIS. Those are being considered, and the user will get an alarm if that is being that gets worse. But I think currently the voltage drop limit is a global setting.
Okay. Then how to define nodes with generation for the optimizer?
Okay, so that's very, for the load flow, it's just negative consumption.
Okay.
For the Pmax and the corresponding reactive power, you just define the, if it's a negative consumption, then will be taken as production in the load flow.
Yeah. Then how does optimizer work with connected generators? A bit similar question.
Okay. We were currently generators there. I see that there would be at least the short circuit contribution from the generators. That is not being considered currently. So there's the link missing from NIS to the optimizer data. I should maybe know a little bit more about the background of this question. Is it MV or LV? And is it more the short circuit contributions we are concerned, or is it load flow we are concerned? So if it's just the steady generation that the generator is providing, negative consumption, that could rather easily be modeled or taken into account in the input as well. But for the short circuit contribution, that might require a little bit more, maybe. But currently, maybe a short answer: no, we are not considering generators at the moment.
Okay, I did also get some additional information. So this was regarding low voltage generators.
Okay.
This question.
Yeah. So no is the answer at the moment, but definitely we would like to discuss about it. So yeah, more.
Yeah.
No more about the background of this requirement.
Okay. Then one more question. Is it possible to set parameters like maximum impedance for different connections?
No. So yeah, meaning what's the kind of the network? How does it seem the network impedance at the point of connection, for example? No, that it's not possible to do it this way. For a low voltage network, you can, however, define a node-specific short circuit requirement. So the one-phase short circuit current can be defined for each customer node in the network. So I guess this could be used for the same purpose indirectly. And also the master results of the master short circuit results can be used as a constraint, as active constraint for the planning or a planning target for the LV network. So if the user wishes, optimizer makes the network so that the master short circuit results are never getting worse, for example.
Okay, thank you, Eero, for your answers. Thank you, everyone, for joining our webinar today. And thank you, Jukka, and Eera for your presentations, and hope to see you again, and have a nice day.